This lesson is on an introduction to functions. You are going to need this lesson for the rest of the school year because we will be dealing with functions from now until June. So make sure you really truly understand what a function is.
All right, so we need to define what a function is to begin with. So if you could get this definition down, you may need to pause in order to get all of this information down, and then you can go ahead and listen to what I have to say. But basically, a function is just a relation in which each input is associated with only one output. So each input can only have one output. If an input has more than one output, then it's not allowed. Now an input would just, when we're talking about these values right here, basically it's just like a coordinate. So an input would be the x value and the output would be the y value. So this is what's going in. It's like a machine, and then this is what's popping out. All right, so let's look at some examples to determine if these are functions or not. So if you look right here, we have a set of coordinates. So this is a relation right here because each value, each x value, each input is associated with some type of output. So for example, this 2 is associated with this 3. This 2 is an x though, this 3 is a y. This 3 is an x, so it's not the same thing as this 3 is associated with a 0. This 5 is associated with 2, so on and so forth. So if you look at this right here, is this 2 as an input associated with any other outputs besides this 3? If it isn't, then this 3 is good. How about this 3? Is this 3 as an input associated with any other outputs besides 0? No, it's not. So the 5, same thing, is only associated with a 2, the -1 is only associated with a -2, and the 4 as an input is only associated with a 1 as an output. So this is going to be a function because no inputs have more than one output. But for example, if I were to add on the coordinates 2, 7, in this example right here, then this 2 as an input is associated with 3 as an output, and it's also associated with 7 as an output. Don't get confused between this 3 and this 3 because, again, this is an input, this is an output, so they're not the same values. So we're going to say this relation right here is a function because each input has only one output. So on your lines on your paper, if you could just write that down, that would be wonderful. Press pause and then press play when you're ready to move on. All right, if you look at your paper, question number 2, the mapping looks a little bit weird. So what I'm going to do is I'm going to draw it out a little bit more clearly so you can kind of see it better. So this is the x, this is the y. This is different than what you're used to seeing because this is a mapping. So it's just showing you what input is mapped to what output. So all of our inputs, our set of inputs are 3, 4, -3, and -8. Now I'm sorry, it printed off weird, so I just want to go over with you what it really should look like. So you got 0 here, -6 here, and 10 here. So what this is saying is that the 3 is mapped to the 0, the 4 is mapped to the -6, the -3 is mapped to the 10, and the 8 is also mapped to the 10. Okay, so I just want to make sure you guys understand this mapping before we actually identify whether or not this is a function. So if you look at this right here, each input is associated with how many outputs. This 3 is only associated with one output. 4, same thing. -3 is associated with one output, and -8 is associated with one output. Although -3 and -8 share the same output, they're only associated with one output each. And let's go back to the definition of a function. It's a relation in which each input is associated with only one output. It doesn't say anything about what the outputs are allowed to do. So any output is allowed to have as many inputs as it wants, but each input is only allowed to have one output. So this satisfies the definition of a function because each input truly has only one output. So if you could write down on your paper on the lines, yes, this is a function because each input has only one output. Okay, so let's look at number 3. I want you to try this one on your own, see how you do, determine whether or not this is a function. Go ahead, press pause, and then come back to me when you're ready to go. All right, so if you look at this right here, the 3 is associated with one output, which is 7. The 4 is associated with one output, which is the 8. But the 2 is associated with 2 outputs. It's associated with the 5. And it's also associated with the 1. So this input has more than one output, which means that it is not a function because each input has more than one output. All right, so if I were to draw a rough sketch of what this would look like in example number 3, I want you to notice that the 2, 5 would go approximately up here. The 3, 7 would go a little bit higher. The 2, 1 would go right here. And then the 4, 8 would go right here. So if I were to look at it, these 4 points right here make my relation, which remember is not a function. Okay, now if you notice, this x-axis right here is the set of all inputs, right? So if I were to draw a vertical line through my inputs, it should technically only touch each point once. Each vertical line should only touch each point once. But if you look right here, this vertical line through the input of 2 touches 2 points, which is not allowed because this shows that the input of 2 has more than one output over here, which again, it is not a function. So we can, if we were given a graph, we can use a vertical line test to determine whether or not something is a function. So if any vertical line passes through no more than one point of the graph of a relation, then the relation is a function. If it passes through more than one point, then it is no longer a function. Even if you have a million vertical lines that only pass through one point, that million and one vertical line, if it passes through more than one point, then it automatically makes the entire relation not a function. All right, so let's take a look at example number 4 on your paper. If I can find one vertical line that passes through my graph and it goes through more than one point, then it is not a function. So for example, this vertical line that I just drew right here passes through 2 points, which means it is not a function, even though this right here only passes through 1 point. This still makes it not a function because I found at least one line that passes through the graph in more than 1 point. So I'm going to say, no, this is not a function because it does not pass the vertical line test. If you could try 5 and 6 on your own and then compare your answers with mine, that would be wonderful. All right, so if you look at question number 5, I can draw any vertical line I want, and no matter where I draw it, it only intersects my graph in one spot, which means that this is a function. Ignore the x and y axes because obviously when you draw the vertical line it will cut through the x-axis, but that doesn't count because it's not actually part of the relation. So yes, this is a function because it passes the vertical line test. In number 6, you found one vertical line, which means, or that passes through more than 1 point, which means that this is not a function because it does not pass the vertical line test. All right, so in number 7, I want to know if this is a function or not, but it's just given to me as an equation. But you should be able to identify that this is a linear equation based on the fact that it has a slope and it has a y-intercept. It's in the format y equals mx plus b. So it starts at -4, and then it would go up 3 and over 1. So here's just a rough sketch of what your line would look like right here. And then if I were to draw vertical lines through right here, sorry, these are as vertical as I can get them for right now, I'm sorry. Each vertical line will only pass through the blue line once, which means that this is a function because it passes the vertical line test. Now, if you could turn on your calculator and actually go to a graphs page, if I were to type in my function, remember the function was 3x minus 4, press enter, any vertical line that I draw through my paper will only pass through the function once, which means that this is a function. All right, so looking at number 8, at this point in time, we don't know exactly what this graph would look like. In a couple weeks, you will know exactly what it's going to look like. but I'm going to graph it out on my calculator and see what it will end up looking like. So if you could press the tab button, go up, and so that you can see the equation of the function that you have before, and I want you to delete it, and I want you to type in the equation of the new function, which is going to be 2x squared minus 8x, I believe. Let me just check to make sure that's right. Yep, press enter, and this ends up being something that you have seen before. It will end up being a parabola because it is U-shaped right here. So let's go ahead and click on menu. Let's zoom out a little bit just so you can see the full parabola right here. So if you look right here, this is my parabola. Any vertical line I draw through it will intersect my parabola only once, which means that this is a function because it passes the vertical line test. All right. So our last example that we're going to be doing in the calculator is number 9. This is the absolute value of 3x minus 2. So again, if you could press the tab button, go up, delete what you have there. Hopefully you remember how to get absolute value. You type in ABS, open up your parentheses, and then we're going to type in 3x minus 2. Press enter. Let's zoom it back to normal. So we'll go to menu, window zoom, and then zoom standard number 5 right here. Same thing, look at your graph. Remember, absolute values would be V's. Are there any vertical lines that I can draw through my graph that will intersect it more than once? There aren't, which means that this relation is also a function because it passes the vertical line test. All right, this piece right here is very tricky, so make sure that you guys are paying close attention because this is the notation we are going to be using from now until the end of the school year. So normally you guys are used to seeing an equation of a graph written out as y equals something. So in this example, y equals 3x minus 7, where x, again, is your input and y is your output. But right here, your function notation looks slightly different. The right side of your equation looks exactly the same, but the left side, I am replacing this y right here with f of x. So this y right here is being replaced with f of x. Now be really careful. It means function of x. It is not f times x, so be really careful as you are doing this. So we're going to write down that this happens where x is the input and instead of y is the output, we're going to say f of x is the output. Okay? All right, so let's look at number 10 and let's try to understand what is being said in question number 10. If you notice, it says if f of x equals this, it's asking us to find each value. So if I were to find this value, I need to understand what it's saying. Instead of f of x, remember that's just replacing y. So this is basically saying y equals x squared minus 4x plus 9. All right, so that's basically what's being said right here. And then in question A, it's asking us to find f of 6. This is basically saying if y equals x squared minus 4x plus 9, can you find out what it is when x equals 6, since this right here is an x value? So basically, all I have to do to figure out what f of 6 is plug 6 in every time I see an x. So f of 6 is equal to 6 squared minus 4 times 6 plus 9. So then all I have to do is just evaluate it. So this is equal to 36 minus 24 plus 9, which means that f of 6 is equal to 21. Now, you have been using function notation this entire school year without even realizing it. So if you could open up your calculator again, and this time I want you guys to have a calculator page. Basically, every time we say 6 and then we store it in as x, we're telling the calculator we have a function where x is our input, all right, and our function that we're going to type in, so x squared minus 6x plus, x squared minus 4x plus 9, I'm typing in right now, this is my output. So I'm typing in what it is that I want as my input, which is 6. Here's my function, and then the calculator is giving me the output. All right. All right, so if you could try question number 10 on your own, press pause and then come back to me to see how you did, that would be wonderful. All right, so in this example, I want to figure out what f of negative 2 is. So every time I see an x, I'm going to replace it with negative 2. So I'm going to say f of negative 2 equals negative 2 squared minus 4 times negative 2 plus 9. So I end up getting f of negative 2 equals positive 4 plus positive 8 plus 9. All right, so f of negative 2 equals 12 plus 9, which means that f of negative 2 is 21, which is my, this right here is my output right here. Now, here's one thing that I want you guys to understand. If I were to write this out as a coordinate, this tells me exactly what my coordinate would be. It's telling me that my coordinate would be negative 2, 21. All right. No, it is not a coincidence that these two examples ended up having the exact same output. You will understand again within the next couple of weeks when we learn a little bit more about quadratic functions and parabolas why they have the exact same value. All right, ladies and gentlemen, I would like you to skip over the rest of question number 10. This is something we're going to discuss in lab because this is a little bit more in depth and I want to be there to make sure you guys are all okay with what I'm talking about. So if you could look at question number 11, we'll just finish 11 up and then the video will be over. It says, if 2x minus 3y equals 12, express y as a function of x. So remember, I'm going to replace the y with f of x. All right, so there's two parts to this question. Part A is asking me to express y as a function of x, and then part B is saying, then find f of negative 6. So let's go ahead and do part A to begin with. So basically, if I'm going to express y as a function of x, I have to isolate the y. So let's go ahead and isolate the y. 2x minus 3y equals 12. I have two options. I can either subtract the 2x or I can add the 3y. I want to avoid my negative, so I'm going to add the 3y. So I get 2x equals 3y plus 12. Now I need to get rid of the 12, so I'm going to subtract it. So I end up getting 2x minus 12 equals 3y. All right, which means that y equals 2/3 x minus 4. Now, all I've done was I've isolated the y value so that I can express y as a function of x. So what I'm going to do now is instead of y, I'm going to say f of x equals 2/3 x minus 4. So I've done part A. I've expressed y as a function of x. And what this is saying is that for every input for x, my function will spit out an output that will work for me. Now I need to figure out what is f of negative 6. So every time I see an x, I'm just going to replace it with negative 6. So this is 2/3 multiplied by negative 6 minus 4. So I'm going to go ahead and multiply 2/3 by negative 6, and I end up getting negative 4. So I get negative 4 minus 4, which means that f of negative 6 equals negative 8. Okay, so again, if I were to write this out as a coordinate, it's just basically telling me that my coordinate would be negative 6, negative 8. I hope you paid really close attention to this because this right here is going to be the foundation of everything we do for the rest of the school year. Please rewatch anything that confused you. I hope your test went well, and I will see you on Wednesday.